All right, here we go, Chapter 3, Trigonometry. We're going to talk about reference angles. So last chapter, we found the exact values for trig functions of certain angles between 0 and 90 degrees. So for instance, we were asked to find the sine of 30 without a calculator exactly. So real quick review, what we did was we drew a 30-degree angle. We labeled the radius of the circle 1. Therefore, the side opposite the 30 is 1/2. The side opposite the 60 is root 3 over 2. We remember that the sine of the 30 degree, we're looking at the y value, and so the sine of 30 turns out to be 1/2. All right. So in this chapter, we're going to start out by talking about these things called reference angles. And what the reference angles will do for us, it will allow us to find the trig values. Oh, that's the bell. The trig values for angles that aren't only in the first quadrant. So we're going to go to angles in the second quadrant, the third, and even the fourth. And the way we do that is the use of a reference angle. So let's go ahead and talk about what is a reference angle. We've mentioned this before in class, but in this chapter we use them a lot. All right, so we're going to start with theta, and theta is an angle of rotation. And this is the same angle of rotation as in chapter 1. We start on the positive x-axis. That's the initial side, and then the terminal side gives us the rotation angle, and that's theta. For every angle of rotation, we have something called a reference angle. Okay? And here's the definition of a reference angle. The reference angle is the acute, it's always acute, so between 0 and 90, the acute angle between the terminal side of an angle of rotation and the closest x-axis. All right? And so I can't tell you how important this is that you recognize that it's always with the x-axis. All right, so we'll remember that and work on it a lot. So let's just do some examples. It's really not that tricky. I think you'll get it. So let's say I have theta is 120 degrees, and I want to find the reference angle for 120 degrees. So here's what I do. I draw a 120 degree angle in standard position. So theta is 120. Then I go ahead and I draw the terminal side back to the closest x-axis. Right? Make the right angle there. And then the reference angle is this one here. And so to find the reference angle for an angle in the second quadrant, we simply take 180 minus 120. So 60 degrees is the reference angle. Okay? Makes sense? Let's do one in the third quadrant. So let's say this time 220 degrees is theta, my angle of rotation. So I'm going to go ahead and put my angle in standard position, right? And so this is theta, and I want to know this angle right here, the acute angle that this terminal side makes with the x-axis. So when I'm in the third quadrant, now instead of subtracting from 180, we take the angle and subtract 180, and we get a 30-degree reference angle. Okay, are you following me? Let's do one more, this time in the fourth quadrant. All right, so this time I have drawn a 333 degree angle, and I want to know if theta is 333, what is the reference angle? Okay, so this time I want to find this. So the x-axis here is 360, so we take 360 minus 333, and we get a 27-degree reference angle. Okay. An important thing to note is that if theta is in quadrant 1, then theta is the same as the reference angle, right? And I hope that makes sense to you. All right? So now what I'd like to do is work backwards and say, what if I say 15 degrees is my reference angle? Find theta, right? So what I want you to think about is a 15-degree reference angle in all four quadrants, all right? And thus we talk about the bow tie, right? So clearly theta in the first quadrant is 15 degrees, the same as the reference angle. Here 180 minus 15 is going to be 165 degrees, right? That's that theta. In this quadrant, theta turns out to be 195 degrees, and in the fourth quadrant, 360 minus 15 is a theta of 345 degrees. All right, that's really all I have. In class, we're going to work on a worksheet that explores this bow tie relationship and how this is going to lead us to finding exact values all the way from 0 to 360. See you in class.